Hi, in this video, we are going to discuss a few questions which were related to the basic concept in this chapter, reaction kinetics. Question number 1, the term showing here is represent rate of reaction. So it is impossible to say that the term is rate of disappearance because when we look at here, disappearance show that the ammonia supposedly is the reactant. But when we refer to the question here, the chemical equation here, ammonia is the product. So this one is impossible. So if you want to relate with the rate of formation, so the correct term to write to represent rate of reaction is plus the concentration NH3 over dt. Okay, in formation of ammonia means that we only focus on the change of the concentration of the ammonia. But if it is about the rate of reaction, we have to consider the coefficient of the substance. So that's why I sometimes in the class I let you know that if without coefficient is either will be representing rate of disappearance if it is the reactants or formation, while with the coefficient will be the rate of reaction with coefficient. However, if the coefficient is 1, if coefficient equal to 1, so rate formation will be equal with rate of reaction. Question number 2. Basically, the question is asked us to determine overall order of reaction at where you can total up or you sum up the order of reaction. At here 1 plus 0, so equal to 1, so it is first order. Second, based on the red constant, what is the unit of the based on the red equation, what is the unit of the red constant? So as we know, the unit for rate of reaction is molar per second, for example, and then the unit of K we have no idea. Concentration of A is M, and the unit for the concentration of B also M. So from here we know that M per second over M square, end up we will have the unit per molar per second. So the answer is the third one. Next, the question asks about what is the formula of the half-life for first order. So that's mean again, just want to remind you all, you need to remember the formula for the half-life for first and second order. So half-life for first order is ln 2 over K. Okay, question number 5. Which of the formula is used to answer this question? So calculate the red constant. We need to determine the K. And then the question let us know 25% of the N2O5 is decomposed in 10 minutes. So you are given the time. And then from here you will have the idea. Concentration at time given will be 75%. Means that after that 75% of N2O5 is left, okay, because 25% is decomposed. 25% dah terurai, jadi yang tertinggal sekarang adalah 75%. And then the initial concentration is 100%. So from here we know that we need to use integrated rate law to answer this question. So again, you also need to remember the formula for the integrated rate law of first, 0, and also second order. Question number 6. So when we read this question, the question asks us determine the rate of reaction, and then they give us the rate of disappearance. So basically, in this question, you supposedly also will be given chemical equation. Then from the chemical equation, you know that you are going to write the differentiate rate law, and then you can do the calculation. just again remind, if the term that with catalyst, with coefficient, so means that it is referred to rate of reaction. Okay. If it is without coefficient, basically it will refer to rate of formation or disappearance based on the substance. Okay. And then we are at the second part of the question. All collision can cause chemical reaction occurs. The answer is wrong. Only effective collision can cause the chemical reaction occur. So how many requirements need to be fulfilled to cause the effective collision happen? There is two requirements. One is correct. The molecule have to collide with correct orientation, and then second, the energy must be equal or greater than activation energy. Next is about the energy profile diagram. Basically, you need to label energy progress of the reaction, means that you have to label x and y axis. Okay, and then also need to label reactants and product. Besides that, then you have to next the shape, that means is either endo or exothermic is correctly label delta H, label activation energy, and also reverse activation energy. Okay, so basically this is how you check whether the energy profile diagram that you draw is complete or no. Okay, if the question gives us the energy profile diagram, it may be not as complete, but if you are the one who draw it then or sketch it, you have to make sure the energy profile diagram is complete. Okay, question number 3, name the substance A. So the substance at the so-called the peak of this diagram is activated complex. If the question asks for what is the condition of the substance A, we will say that it is transition state. Okay, state the condition substance at A at, so like just now we mentioned, is transition state. Calculate the reverse activation energy, means that we have to treat that the reaction is reverse. So means that at this moment, at this part here will become the reactants, and the reactant need to climb up this peak so that it will become the products over here. So this is called reverse reaction. So the activation is the distance between reactant and also the activated complex. So that's mean for the reverse activation energy, it is from reactant here until the peak here. So total up, this is 30 plus 30, so will be equal to 60 kilojoule per mole. Question number 6, related with the Maxwell-Boltzmann distribution. So they ask us which one is at the lower temperature. So in generally, we know that if the temperature is increased, the molecule will move faster. Okay, so if the molecule move faster, that means the kinetic energy is increased. Or if we look at here, the x-axis here is the speed. So that means the speed also will be increased. But then the question is asked us to at the lower temperature. So that means the speed of the molecule is lower. So that's why T1 or this red line is represent the lower temperature. Question 7. This is about the Arrhenius equation. So this is the original Arrhenius equation, we so-called original. Okay, but then we will take log at both sides. So it will become ln k equal to negative EA over RT plus ln A. So and then we will relate this with the linear graph. Okay. So when this is the linear graph, we roughly will get this idea. Ln k is equal to y, and then ln A will be the c. So and then we know that this is the negative slope, and then EA over R is the gradient. So 1 over t is the x-axis. So which one is represent the x-axis is 1 over t. And then when you substitute the value inside the graph, make sure it is in the unit of Kelvin. Question number 8. The activation given is kilojoule per mole, and the factors is 10 per molar per second. So from here we know that this is the second order reaction. Find the rate constant of this reaction at 300 Kelvin. So because in here we only have one temperature, so basically we are going to use the formula A. So at where we didn't know the rate constant, question given us kilojoule per mole. So do remember that you have to convert to joule per mole, because the gas constant value that we use is 8.314 joule per mole per Kelvin. Okay, then the temperature is given, the A also given, so we have one unknown only. So means one unknown of the rate constant, which is the K. So we have to use this formula A to solve this question. Okay, so basically I think we already again roughly go through the basic idea in this subtopic, at where how you're going to solve the question given. So hope this video is helpful. So we will continue with the another one video, which with the students working step. Thank you.